Alright guys, more on 1800, STAT 1800 study guide for the final exam. I'm not going to make any predictions anymore. I'm a popular guy today for some reason. Lots of people are stopping by to say hi and get help and stuff. So I'm going to work 26, and I don't know how far we'll get, but we'll get however far we get. So the owner of a moving company, what they wanted to do here, looks like they're trying to predict the number of labor hours that it'll take for a move based on the cubic feet of, I guess, furniture and stuff that is moved. So they have data for 20 moves. So guys, first thing I'm going to do is, these are the kind you kind of like because they have the raw data, so you can open that up into StatCrunch. And again, I check row 1, make sure that those are numbers. So the very first thing that it wants us to do is to construct a scatter plot. So that's going to be easy. So we're wanting to predict labor hours, so I put that as my Y. And we have a strong linear tendency here. Ranges from about 250 to about 835. So I need a strong linear pattern that ranges from about 2, so we know this can't be it, even though it kind of looks that way. This can't be it. That's not a linear pattern. This is not a linear pattern. So guys, we're pretty much stuck with C. Assume a linear relationship, the least squares, so we want the slope and the intercept. So guys, again, use well, that's not going to work. So let's go to Stat, go to Regression, go to Simple Linear, and use the cubic feet to predict the labor hours. Wow, this is crazy. I have never been interrupted as much as I have for here, so on this. Okay, so hypothesis test. So we should be able to get our information here. So it looks like the estimate for the intercept is 1.061, and for the slope is 0.046. It's actually getting pretty funny that how much I'm getting interrupted today. So B0, 1.061, and B1 is 0.046. Now the next thing, interpret the meaning of the slope. So again, the slope, the generic interpretation is as x increases 1 unit, the predicted value of y changes 0.046. So for each increase in 1 cubic foot moved, the number of labor hours is expected to increase by B1 hours. So makes total sense. Predict the mean labor hours for moving 700 cubic feet. So guys, I would need to take 700 times the slope, which is 0.046. And then I would want to add to that the intercept of 1.061. So rounded to 2 places, I get 33.26. What should you tell the owner of the moving company about the relationship? Well, as expected, the labor hours are affected by the amount moved. As the amount to be moved increases, the labor hours increase, and that's because this B1 is a positive number. And you could see that also from the scatter plot. All right, the problem facing a manager is to assess the impact of factors on full-time job growth. Specifically, the manager is interested in the impact of total worldwide revenues and full-time voluntary turnover on the number of full-time jobs added in a year. Data were collected on a sample of 97, so I'm going to write that down because that's going to be important. For multiple linear regression was found using the total number of full-time total and full-time voluntary turnover. So the sum of squares regression is like 20 million something. The sum of squares error is 19 plus million. So the correct hypothesis is going to be that, so we have two predictors, so we'll have the B1 equal B2 equals 0, and then we'll say at least one of the beta j's, 1 and 2, is equal to 0, is not equal to 0. Calculate the F statistic. This is going to take some work. So we have two independent variables. So guys, I'm going to need to get some information written down before we can go over there. So 20 million 563 863, and then the sum of squares error. Well, I don't know why they have to have such big numbers here. 927 283. All right, so here is what I'm doing over here. So what I need to do now is I need to come in with the degrees of freedom, and so the degrees of freedom are just the number of predictors, which would be, we have two predictors, and then the degrees of freedom for the sum of squares for the error is just n minus k minus 1. So we have 97. Number of predictors is 2 minus 1 will be 96. Now the next thing we need to do is calculate the mean square, and remember that's this value divided by this value, and then the mean squares for the error term is this value divided by 96. But the F statistic is just the sum of squares for the regression divided by its degrees of freedom divided by the sum of squares error divided by its degrees of freedom. So what I can do here, hopefully you guys can see this, I need to be able to see my numbers. What I can do here is I can take 20,563,863 divided by 2, and then divide that by 119,927,283 divide by 96. So I'm just doing it all in one kind of one stop. So I get 8.23 as the F statistic. Well, guys, I must have a typo someplace. So sum of squares regression should be 20, 563, 863 divided by two predictors, and then take that amount and divide by 119, 927, 283 divided by 97 minus 2 minus 1. Oh shoot, guys, I had that wrong. So it should have been 94 instead. So the correct answer should be 8.06. You guys probably saw that. In the comforting that your statistics professor takes 97 minus 2 minus 1 and gets 96. Guys, that's horrible. All right, so the p-value here, we're going to use the f. So again, 8.06. So we're going to go to the f distribution. And I want degrees of freedom of 2. And 94. How about, and we want greater than 8.06. So we have 3 zeros, 0.0006. So it would be 0.001. All right, state the conclusion. Well, our p-value is less than our level of significance. Therefore, we reject the null. And there is sufficient evidence to conclude that we have a linear relationship between the values. Interpret the meaning of the p-value. The p-value is the probability of getting an overall test statistic equal to or less than. That can't be true. The p-value is the probability of getting an overall statistic equal to or greater than the sample result, assuming there is no relationship. The p-value is the probability that there is a linear relationship between. That's not true. The p-value in at least one of the predictors. So, guys, this one seems to make the most sense for me. And you too. Now, compute the coefficient of multiple determination, r squared. So, guys, going back over here, remember that we can get the sum of squares total by adding these two. And the r squared is just the sum of squares regression divided by the sum of squares total. So if I don't commit a typo, 563, 863 plus 119, 927, 283. So I want to take 20,563,863 863 divided by the total. So in other words, what I did is I added these two together, and right here I got 140,491,146, and I divide this number by this number, and I end up getting 14.6%. Okay, so this is round to 4 decimal, okay? 0.1464. It's awful. So interpret r squared. R squared tells us the coefficient of multiple determination tells us that 14.64% of the variation in our y, which would be what we're trying to predict here. The regression model. So we are okay, specifically the manager is interested in the impact of the total worldwide revenues and full-time voluntary turnover on the number of full-time jobs. So jobs added can be explained by this. The adjusted r squared, I'll have to look that up. I forgot what the formula is on that. So it looks like the adjusted r squared is 1 minus r squared n minus 1 so it looks like it's this. So just totally formula driven, no big deal here. So the r squared is 0.1464 times the sample size of n minus 1. I forget what our sample size was there. 97. So we have 97 minus 2 predictors minus 1. So if we can put that in our calculator correctly, I'm going to multiply this out first. So I'm going to take 1 minus 0.1464, and I'm going to multiply that by 96. And then I'm going to divide that by 94. And I'm going to take 1 minus that answer. So I get 0.128238. All right, number 28. Use the following information from a multiple regression analysis to complete parts A through C. So we have our sample size, we have our beta 1, our beta 2, our standard error for beta 1, our standard error for beta 2. So which variable has the largest slope? Well, it's 30 in units of the test statistic. So the largest slope in units of a test statistic, well, 30 divided by 8 is smaller than 30 divided by 4, so x2 is going to have the largest. Construct a confidence interval for okay, so for beta 1, we're going to need beta 1 plus or minus our t critical times the standard error for beta 1. So beta 1 is 30 plus or minus. We need our t critical times SB1, which is 8. Gosh, it'd be nice if we had the data here. We could just plug and chug. So, guys, we have sample size n equal 20, and we have 2 predictors. So my degrees of freedom are going to be n minus k minus 1. 17. And it looks like we need a 95% confidence interval. So, T-stat, calculator, T, between, 0.95, degrees of freedom 17. Looks like our T critical is 2.1098. Now we're having fun yet? So I'm going to take 30 minus 2.1098 times 8. And then I'm going to do the same thing, except I'm going to add it. So I don't know, right or wrong, rounded to 4 decimal places, I get 13.4 0.1216 up to 46.8784. At the 0.05 level of significance, determine whether each independent variable makes a significant contribution. On the basis, indicate the independent variable to include in this model. So for x1, we would have that h sub o beta 1 is equal to 0, and beta 1 is not equal to 0. Find the test statistic. Well, guys, the test statistic is just going to be 30 divided by 8. So 3.75. Find the p-value. Well, the p-value will be found 3.75. I need to write that down. I'll never remember that. So we want degrees of freedom for that one predictor will be n minus 2. So 18. And we want greater than 3.75. We'll need to multiply that by 0, so 0.00073. So we get 0.00146. 15. Is there evidence that the variable x1 contributes to a model already containing x2? Yes, since the null hypothesis is rejected. Choose the correct hypothesis for x2. Well, that's going to be beta 2 equal to 0, beta 2 not equal to 0. The big thing here, this is really redundant, it's just don't make a silly mistake. The test statistic for beta 2 will be 30 divided by 4. So 7.5, but it wants us for some reason to go out 3 places. Find the p-value. Well, very small, multiply that by 2. You know, we're just to 4 places is just going to be 0.0000. Is there evidence that the variable x2 contributes to a model already containing x1? Yes, since the null is rejected. So both these variables contribute to predicting y. On the basis, which one? I'm going to include both of them because they were both significant. All right, good deal. Number 29, profitability remains a challenge for banks and thrifts. With less than $2 billion in assets, the business problem facing a bank analyst relates to factors relative to total assets. Data collected from 20 community banks resulted in the regression model where Y is ROA, efficiency ratio, and risk-based capital. All right. Okay, plot the residuals y1. Choose the correct graph. Well, the first thing we need to do is we need to calculate and we want to store the residuals. Now we want to replicate this graph, so we want our predicted y. Actually, we should have stored our predicted y2. So now we want our predicted y, and let's take a look again. Our predicted y is on the horizontal axis. Our residual is on the y-axis. And we have a kind of a negative tendency here, and we have a lone kind of outlier up here, so that's what we're looking for. This one tends to look at the pattern probably, or model the pattern as closely as possible. Plot the residuals versus x1. So we've got this lone value up here, so we need to try to find something that kind of replicates that. So it looks like to me it would be D. Plot the residuals versus x2. Okay, so we have a very similar to the first time. So again, I'm looking for that lone dot up here that kind of defines the scatter plot. Plot the residuals versus time. There's no time component. In the residual plots created, is there any evidence of violation of the regression assumption? Well, when we look at this first of the residuals versus the predicted, we want to see a shotgun blast randomness. So I would say yes, because there appears to be a pattern. All right, guys, last one. I'm happy. Seems like forever. So this is a binomial distribution. So we have three. We have a population proportion of 0.71. Find the probability that x is equal to 0. So gang, what I would do here is I would go to STAT calculator, and I would go to binomial. So we have 3. And the proportion was 0.71. And we want to know the probability that x is equal to 0, right? Yes. So 0.0244. All right, gang, I've done all the damage I can do. I think I tried to go through some of these too quickly and made some little stupid errors, but I think this should have helped you. We ended up getting them right in the end, so that's all that mattered. So, guys, take care. Good luck. Study hard. As you can see, and it really kind of hit home as I was going through this. There's a lot of information here, and I even got a little scatterbrained on a couple of them. So, you know, I think it's going to be critical that you take time and go through these, and also it's going to be critical that you prepare your study guide, your notes that you get to use on the exam, that you put a lot of thought into what needs to go on those. So, guys, I'm done. Take care.